Hey, what's up, everyone out there? I thought today we'd go over some skills for one of the units in Khan Academy. I got a request from one of my subscribers to go over something from the computations, the unit on multiplying decimals. Have you guys started that one yet? Well, there's 11 skills in multiplying decimals. You see 51 people have mastered. Mr. Khan says we should estimate first. Just kidding, that's me. But they also agree estimating is great to help you with multiplying decimals. That's something we'll be doing today. I'm looking at which one doesn't have the most mastered, and only 5 people have not started this. But we go further down the line, there's things that 17 people didn't start. I think looking at it with pictures could be good for us to practice. We have 5 people who are having trouble with that, and up to 4 digits we'll go to the end, like the final skill that's maybe hard. So without further ado, let's get into it. These are multiplying decimals with like an area model. All right, here we see in red that, well, the total is one whole, right? So this is part of a whole times part of a whole. If this whole thing is 1, this is 1, 2, out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. This is 2/10 or 0.2. In blue, ooh, it's half of the whole, right? This is 1, 2, 3, 4, 5 out of 10. So it is 5/10 times 2/10. And they kind of overlap it, and this purple part here is 5/10 of 2/10, which is the same as half of 2/10. Let's look at 5/10. This is 5/10, 5/10, 5/10. 2/100, no. 2/10, yes. 2/10, yes. 2/10, yes. What do we have? With one of these, how much is this of the whole? It is not 10 wholes, no way. It's either a tenth or 1/100th. Well, let's see. If I did it as fractions, two tenths times 5/10, or I kind of actually like it more, 5/10 of 2/10, or half of 2/10 is 1/10, right? We can multiply across. That's 10/100ths. Which one's equal to 10/100ths? No, that's 1/100th. Bang, it would be this. Let's do another example. All right, this figure is not to scale. Good. So this is like a partial product area model. Remember this? It looks like foil. We could foil with 4 partial products. Here we have 4 wholes and 5/100ths times 310. So that one's pretty basic. It's 4 and 5/100ths times 310. Not 300 and 0.10, no. 310, 310, yeah. But this is 4 and 5/100ths. 4 and 5/100ths. 4 and 5/10ths. 45, no. This one is like the one we just did. We see going this way, oh, it's almost all of it. It is 8/10 times 6/10. So we're getting 6/10 of 8/10. 6 times 8 is 48. And it's going to be 48/100ths. 10 times 10 is 100. 48/100ths, not 48 wholes. 48/100ths. Oh, is it 6/100ths plus 8/100ths? No, it's 6/10 and 8/10. All right. So that is one area of looking at area models. Let's get into multiplying. And Mr. Dick says you should estimate first. Maybe I don't have to type my name. Estimate? Estimate first. Bang. Let me do that to the side. That to the side. Copy paste it all in. We're going to do 3 problems. I suggest you maybe get out a piece of paper. You'll probably do better instead of just watching me. Do some of this alongside. You can talk to me. I won't be able to hear you, but I think it'd be better just to even scratch this out, even if it's just a Post-it note, something for you to not just see something, but to actually do it. So you want to pause, get a Post-it note. Don't just watch this. You're not going to be able to do it on your own very well without writing it down. Get that muscle memory. Okay, here we have 64 hundredths times 5.3. And you know what I would estimate? Well, this is less than 1. So like 1 times 5 would be 5. This is less than that. So we're going to have less than 1 times 5. It's going to be less than 5. So your estimate could be, I know it's less than 5. Another thing we could do, just for fun, what if I said this is like 0.5? Maybe I'll do this by my estimate. So 1 times 5 is 5. That means my estimate is going to be less than 5 because this is less than 1 times 5. Yeah, it is less than 1. What if I think of it as 0.5 times 5? Or what is half of 5? Do you know what half of 5 is? 2.5, right? So maybe my answer will be like more than 2.5 because this is more than half, or 5. If I got an answer like 13, that doesn't make sense. If I got an answer like 100, that doesn't make sense. If I got an answer like 0.3, that doesn't make sense. Let's pick a number that's going to be between 2 and 5. 3 point something sounds awesome. 4 point something sounds awesome. 3 point something sounds awesome. 30 something? No. 0.3? No. We're going to estimate. And that's what we do. Now we can go in and treat these kind of like whole numbers. I don't actually have a preference if you like to put 5.3 times 0.64. I don't care. Don't put an extra 0 in there. I don't do that because then it's like, oh, 4 times 0 is 0. Like you're just multiplying the stuff times 0. Honestly, I mean, if you want to not even line up the decimal point, we're not adding or subtracting. We're going to be multiplying. So I don't even care if it's like this. It's not even a big deal. I'm going to make some math teachers mad, but putting in an extra 0 is not necessary. Maybe we still line them up, but I'm not putting in an extra 0. I'm not doing it. Like, fine, if you want me to, because you're such a stickler, I'll do it. But I'm just going to be throwing in random zeros. 4 times 0 is 0. Okay. 4 times 3. So there's going to be 4 facts we kind of needed to do here. 4 times 3 is 12. It's basically just normal whole number multiplication, and then we estimate. 4 times 5 is 20 plus 1 is 21. Don't even worry about where that decimal place goes right now. I'm not gonna go there. All right, this 6 is a digit higher, right? It's in the tens place. So we increase the place value by putting a 0 there. Since we're not in the hundredths anymore, we're in the tens place. And then if you really want to put this 6 times 0 is 0, okay? All of this, look, it's just an extra rows of 0. Who cares about this? 6 times 3 is 18. Ooh, we already have a 1 there. 6 times 5 is 30 plus 1 is 31. Notice how it's a little sloppy, but I still lined up my digits very neatly. Don't need those zeros. That's why I don't care about putting it there as a placeholder. 2, 9, 3, 3. Okay, my friends, go back to our estimate. where should I put this decimal place? It's going to be about between 2.5 and 5. I'm going to put it here. So that means this whole side, that's where the decimal place was. Yeah, 100th of 100th is a 10,000th. 100th of a 10th is a 1,000th. 100th of 1 is 100th. Nice. So that's what this decimal place goes. A 10th of 100th is a 1,000th. A 10th of a 10th is a, oh wait, a 10th of 100th is here, 1,000th. A 10th of a 10th is 100th. A 10th of a whole would make a 10th, and then we have the spillover in the holes. Yep. So that's how we get the answer, 3.329. All right, boom. We're going to speed through this one. All right, now let's try this next one on our own. We are going to estimate first. 2.32 times 5.6. Sorry, y'all. It's like 8:30. I'm getting a little tired. Let's estimate. Well, if this was 2 times 5, it would be 10. But look, the real numbers are more than that. So it's going to be more than 10, maybe 11, 12. Let's go round way up. Let's like not what it's close to. Even 3 times 6. Both of these numbers are less than 3 and 6. So if I multiply that, 18. So I know our answer is going to be between 10 and 18. If the answer is 13, sounds good to me. If the answer is 14, sounds good to me. 15, sure. 16, sure. 8, no. 1.3, no. We can estimate. Well, 2 point something times 5 point something, maybe 14. Come up with your estimates now. People at home, what are you thinking? What are you thinking? Wits and wagers. What do you think? 15? Get a guess. And then we're going to do the multiplication. All right, I'm going to just start. This one has 3 digits, and this one has 2 digits. I don't even have a real preference. Conventionally, if you line it up, I would not put it. I just think this is silly to put a 0 here. I get why, like, oh, it's nice, it's neat, it's in order. But then when you're actually multiplying, that's like 0 times 2, oh, that's 0. 0 times 3, oh, that's 0. 0 times 2, oh, that's it. Like, that's not helping us. Really. It's looking neat by having them all lined up, but I would rather just start here. Let me know, teachers and friends, if you would even move this over, or if you line up the decimal points, or if you rather move it. Maybe you do it like this: 2.32 times 5.6. Like you line up these, but then it feels a little weird because they're different values. Like the tenths place, they're in different place values. Or do you put bigger on top? 5.6 times 2.32. I don't do this though, because then there would be 3 partial products. I'll do it, but I like in 5th grade we multiply 232 times 56. We know how to do that. Multiplying with 3 digits on the bottom will be unheard of, but it's kind of fun. And I said I was going to go fast, but I guess not. We'll get the same answer, but this one we're going to have 3 partial products because we're going to do 2 times 6, 2 times 5, 3 times 6, 3 times 5, 2 times 6, 2 times 5. So we'll have actually like 3 numbers to add. That's actually kind of cool. So I'll do it. But that's the reason why I guess I put the one with 3 digits on top. All right. 6 times 2, you know how to do that, is 12. I'll just put it here. I don't know. 6 times 3 is 18 plus 1 is 19. 6 times 2 is 12 plus 1 is 13. Okay, let's cross these off. All right, now I have 5 holes. I kind of know where this Do you know where this decimal place goes? If it's 2 times 0.6, it's not going to be 213. I think it's here. But let's not do it next. Let's not do it right now because we are going to estimate. All right. Now we do 6. Oh, do I line it up here? No, no, no. This 6, the 5 I'm going to do, sorry. The 5 is in the next place value. So put a 0. Bang. Or maybe you even just skip that. I don't know what you do. I'm cool with anything. 10, 15, 1, 16, 10, 11. Are you doing this on your paper? Okay, so now we have 2, 9, 9, 2, 1. So where does this decimal place go? Look at our estimate. Look at our estimate. It's between 10 and 18. Bada bing, bada boom. 129, that doesn't make sense. 1.2 does not make sense. 12.9. So that means our decimal point was here all along. This would be 2 times 0.6. Yeah, it would be 1.3 because that's like about half of it. All right, 12.992. Now this way I'll do because I'm kind of interested in it, but we're going to do it in different colors. So let's do this. 2 times 6 is 12. 2 times 5 is 10 plus 1 is 11. I'll just line up. This is getting crazy. All right. This 3 is one value up. Put a 0. Smile. 3 times 6 is 18. 3 times 5 is 15 plus 1 is 16. Then this 2 is 2 values up. We get a double smile. Yeah, you don't need to put smiles. You can just put zeros. 2 times 6 is 12. 2 times 5 is 10 plus 1 is 11. Oh, it's just like the first one, but 100 times the value. All right, we add these up. I'm running out of room, huh? Oh, I need to go higher up. 1, 2, 9, 9, 2, 1. Oh, it's 12.92. All right, let's do one more. Okay. Mr. Dick says you should estimate first. I know 1 times 23 is 23. This is not one whole, right? This is basically like half of 23. Oh, 0.5 or half of 23. What's half of 23? Ooh, actually 24, right? Let's do 24. Go back because it's 23.9 and that's going to be easier to do actually. Bad, Mr. Dix. Sorry. All right. Half of 24 is 12. So it's actually really close to 12 because this is really close to half. And that's pretty close to 24. So I think 11 point something, yeah. 12 point something, yeah. 15, no. 2.4, no. 11 or 12. Okay. I'm going to have my 3 digits on top. 23 and 48. It's not, and I put this, I'm going to just do it like this. I don't even know I'm taking a stand. It's not a big deal to me. I just know to line up the digits. Maybe someone else can convince me. Right now I'm just making this. 72, 8 times 3 is 24 plus 7 is 31. Are you doing this on a paper? 8 times 2 is 16 plus 3 is 19. Got it. Okay, now we have this 4. Is one place value bigger? So we're going to put a 0 here to increase the value. If I multiplied and put it here, that wouldn't be the same because that's one place value bigger. All right. 4 times 9 is what? Are you doing this? 36. 4 times 3 is 12 plus 3 is 15. 4 times 2 is 8 plus 1 is 9. Let's add these up. 2, 7, bang, bang, bang. What did we think it was going to be? What did we think it was going to be? 11.472. Hey Siri, what's 0.48 times 23.9?
It's 11.472. 0.48 times 23.9 is 11.472.
Show the kids at home. That's how you do it without Siri. Okay, that was longer than I wanted, but I hope it was still helpful. We did some problems looking at an array model, or area model. We multiplied. I don't have a preference of where you line up. I think it's better to do the 3 digits on top than the 2 on the bottom. But either way we go, we should estimate, think, hey, it's going to be about 11. Bang, treat it like whole numbers, and you'll be fine. Let me know how it goes.